It's a lot of writing. It's a lot of writing during algebra today too. Been a lot of writing.
So much writing.
Alright, so 2-6 part 1 is algebraic. If we're going to do algebra today, what do you think we might do tomorrow? What comes on after algebra? What class do you take after algebra? Geometry. So tomorrow we're going to do geometric proofs, but really they're going to be algebraic proofs in disguise. We're going to really do the same thing tomorrow, but just tack on a tiny bit of geometry.
Alright, so we do have some writing today, so get yourself used to that. I'm going to apologize in advance.
But you don't, all your homework is online, so you don't actually have to write anything on your homework. It's just for your
So we're going to start with some vocabulary words. The first group of words we're going to talk about are all going to be under this heading, Properties of Equality. And we're going to talk about a few different properties of equality, but I want to keep this part separate from our next part. So I'm going to give properties of equality kind of this blue title. If you like to use colors, you can use a color, just because we're going to have some different types of vocabulary words. No, I can't help that.
I just wrote it last time. She didn't even tell me how to write it.
Alright, so our first property of equality that we're going to talk about, and notice I'm going to bump this over a little bit because it's going to be under that properties of equality heading, is the reflexive property of equality. So the full name is reflexive property of equality. That is a lot to write for us right now, so we're not going to write it all down. We're just going to keep it under this heading. If you feel like you really want to remember like the official geometry term, you could write reflexive properties of equality, or you could even write POE for properties of equality, okay? But I'm just going to write reflexive.
Now, reflexive is similar to that word reflection. When you see your reflection in the mirror, whose reflection is it? Who's in the mirror? You. If my baby brother sees his reflection, if he's only like 8 months old, who does he think it is? Just like some other baby. He's like, oh, there's another baby. But eventually we realize that when we look in a mirror, who do we see? Ourselves. Okay? So reflexive is similar to that idea of reflection. It's really just naming something as itself.
So we're saying something is equal to itself. I'm going to mark that, equal to itself. And for example, that means we could say something like 5 equals 5. 5 is equal to 5. If I have a variable like j, what is j equal to? J. It's equal to itself. All right, the next property of equality that we're going to talk about, so I'm going to stick right along here, I'm not going to move back over yet, is the symmetric property of equality. I'm just going to write symmetric. what word do you kind of see in that word, symmetric? What do you think of? Symmetry. What is symmetry? Think back to art if you took an art class. What do we usually describe using that word symmetric? Yeah, it's the same on both sides. So we might describe a shape, like for example, if we drew a heart. My heart is not going to be very symmetric right now, but it should be.
That was pretty good.
That means this side and this side would be the same.
So symmetric, you might like fold in half, and when you fold it in half, it's the same. Or there's lots of symmetry in like snowflakes.
Mm-hmm. Go when it's time, sir. So you might, whenever it's time, you can just go. Okay. A butterfly is a good example of symmetry. They have their wings the same on each side. When we're talking about something as a symmetric property of equality, that means we can switch around that equal sign. For example, if I say 3 plus x equals 6, how could I rewrite that using the symmetric property of equality?
So if you like fold it in half, what would end up on the other side?
6 what? Yeah. I don't know why I wrote it up.
But we're not going to switch around the other side. We're just going to flip it so it's on that side. So 3 plus x. Because that would be that commutative property, and then we're just involving lots of other things.
So instead of saying 3 plus x equals 6, we could flip around those two parts on either side of the equal sign and say 6 equals 3 plus x. All right, the next we're going to write is transitive.
What does transitive kind of sound like or look like? What other word kind of is in that word transitive? Transition or like a transit. So transition, what does it mean to transition from like a paragraph to the next paragraph? What would be an example of like a transition word? Yeah, moving from area to area, or like saying next we go to this, right? Transitions. Okay, so a transitive property of equality is going to be similar. We're going to be like moving along. So if I say that Hamza and Rama are in the same grade, I know that. And then I talk a little bit about their grade. I'm like, okay, they're really awesome. They're really cool. Like, I'm graduating on time. It's amazing. Life's great. And then I say, okay, but Hamza and Hodan are also the same grade. Who do we know is in the same grade beyond what I said? Who are you assuming? Rama and Hamza are in the same grade. They're going to graduate on time. It's going to be great. And then Hamza and Hodan are in the same grade. What do you know? You know what I said? What do you know about all three of them? They're all in the same grade. So is Hodan in the same grade as Rama? But I never said that.
You just know it.
How do you know it?
Because me and him are the same grade.
Yeah, because I said Rama and Hamza are the same, so Hamza and Hodan are the same, so we know all three are the same, and we can do those endpoints. So that's kind of that transition.
Okay, then
If
go ahead.
A is equal to B, and we know B is equal to C, we know in the end we can do that transition. We can start at the beginning, the A, and that leads us to the end, C. That should look a little familiar from chapter 2A. Does anyone remember what property was that really similar to in 2A? It was in our last lesson of 2A. Yeah, it's really similar to the syllogism. Syllogism was that if A leads to B, B leads to C, we know A leads to C. This time it's not a cause and effect, it's just we just know they're all equal. We are really going to use that transitive property tomorrow in class during our geometric groups.
All right, we have two more properties under that properties of equality heading, and then we have one more that doesn't really fit with properties of equality. The next one we're going to talk about is substitution. So think about that word substitution, or to substitute. If Miss Morrell was gone tomorrow, and I was gone tomorrow probably, we might have a substitute teacher. So if she and I say, too bad we're going out for coffee instead of period 5, then we would have a substitute teacher. Do you think they would just let my 7-year-old come in and substitute? If I was like, oh, it's fine, Max is just going to watch class for the hour, I'm going to go have my coffee with Miss Morrell? Why not? Yeah, that'd be awesome, wouldn't it? But if they were going to find a substitute for us, they would need to substitute someone equal, right? Think of this in sports. If you were a forward and you needed to sub out, who would they put in? Would they put in the goalie to take your place? Who would they put in? Another team member who probably plays the same position, right? So if you needed to sub out a forward, you would sub for another forward.
Or at least someone who plays offense.
So substitution means we need to switch it out, but for an equal amount. So this is that really important part, this equal amount part. So if you've been marking up at all, maybe mark that a little bit. Switch it out, but for an equal amount. For example, I could write 3 plus 7. Or, what else could I write? If I wanted to substitute 3 plus 7, what is 3 plus 7 equal to? 10. So instead of writing 3 plus 7, I could just write 10. I'm actually going to change this a little bit. If you're a super fast writer, maybe go back and change it too. We already know that that's equal. That would be really similar to using some other properties. But for substitution, it means instead of writing 3 plus 7, we could instead just write what it's equal to, which is 10.
Guys, remember from last chapter, what did that arrow mean? Remember it was an indicator for an if-then statement. So if we have 3 plus 7, then we can just write 10.
All right, the next property of equality is kind of a long one, but it's one you're really familiar with. That's when we can use, you did this on our warm-ups. So if you look up here at Damien's first one, when we looked at his first step, he knew that to undo minus 7, he had to add 7. To undo that multiplying by 6x, he had to divide by 6. The last property of equality that we're going to talk about is addition, subtraction, multiplication, division.
I know that like this maybe because they were technically all four separate, but they all
Sure.
I don't know what I'm doing with these guys.
Okay.
But you do you. I do. So it's really four different properties, but they're all just stating really the same thing.
So with all of these properties, if we had an equation and I wanted to undo subtracting 7, I would add 7. But remember, what I do to one side, I have to do on the other, right? So we have to do it on both sides.
So if you were doing a -4 and -4, which one of those would be that property? If you were doing minus on both sides. Yeah, they're so talkative today.
So quiet.
Which one means minus? Add, subtract, divide, or multiply? Subtract. So that would be the subtraction property of equality. So you're going to just use one of those for each of them.
All right, now we have our last property. It's not actually a property of equality, so I'm going to move my little bullet right over here back to the pink line. And the last property is distributive property. And I would guess you remember distributive property. We did talk about it during our warm-up too, but what does distributive property mean? What are we doing when we distribute? Multiply for what? What's our purpose? So if you had this problem, Owen, can you see this behind this post? Is this okay? If we had this problem from our warm-up, 3 times the quantity of 2x plus 4, why would I be distributing? What am I trying to get rid of? The parentheses. Yeah, I want to work in those grouping symbols and I want to undo those parentheses, right? So you might remember distributive property means we're going to multiply to undo parentheses. And that would look like this. And you might, if you had Miss Morel or I, you might remember we have this little sound that we make, which is pew, pew, which, I don't know, Miss Morel started doing it and now I can't stop doing it, so now.
You had Mr. Tyson, what does he call that property?
Oh yeah, he has a funny name too. He calls it the rainbow. Like you make a rainbow. Okay, so that means we would multiply A times B plus A times C. If that seems weird to you and you want to write it as numbers, you sure could. So that would look like our problem here. And then we would have 3 times 2x plus 3 times 4. We would be left with 6x plus 12. If you want to write it in numbers, go for it. If not, you can just use the A's and B's. All right, now we have an example we're going to do together, and our example takes up quite a bit of space, about half a page. So I'm going to run out of room on mine. I'm going to have to go to the next page. If you wrote smaller or you wrote close together, you can try to change it on the bottom of your page, but you probably need at least 10 lines. Everybody got it? All right, so here's our example. Our directions might say something like, write a 2-column proof. Write a 2-column proof. And then we'd be given some information. So the information we're given says, if 36 equals 3 times the quantity of 2x plus 4, then x equals 4. Now we already did that in our warm-up, right? So someone tell me, is this true or false? If you don't remember, you can look at the back. It's up there. It's true. That's not our job today. Our job is not only to solve it. Our job today is to prove it. So we're going to write our steps, and we're going to prove each step to show how we know that this is true. It tells us to write a 2-column proof. Remember, columns means they go up and down. So I'm going to kind of draw a line down my paper halfway, like this. One side is going to be for our statement, and the other side is our reason. And this side that says reason, this is where we're going to write our property that we use, and the statement is we're going to write the actual math, like the actual work we've done.
So it's going to look really similar to what we already did. But now every time that we write something new, every time we add a new line, we have to say what says it's okay to do that. So why don't you just go to the next page and do this, and then we'll fill the rest after. Because Leah's got to do this too again. I'd go to the next page and do this to your answer.
Are you okay with me using numbers if I color them?
It just gets to be so much.
Right. Is that just what we're going to be used to seeing moving forward?
Normally when it's like numbers, I like to use letters. When it's
But what about other places?
then in geometric, we'll use numbers. So it goes between the two.
Okay.
They have to know both.
Okay. Then we can do letters first. All right, so in order to keep ourselves straight so that we know which statement goes with which reason, we're going to number or letter them the same. Since we're doing a lot of our work with numbers, we'll use letters this time, but when you get to your practice work, if you see them numbered, that's okay too. So we're going to start with A. And then on this side, we'll also have A. So we can keep track and keep it organized. All right, so we were already told if 36 equals 3 times the quantity of 2x plus 4. So I'm going to write that down. Now, have I done any math with this yet?
Did you ever do any math to see the problem in the warm-up? No. How did you know which problem to do in the warm-up? We told you to. We said do the problem.
So that first reason is always going to be the same, and your reason will always be given. That's what I was given. I didn't have to do anything yet. I didn't have to know anything yet. I was just given this. So when you go to take your test, which is not for a long time, so don't even stress. Oh my God, that's so worried.
If you flip to the front of your cover, look for that 2-column proof. It's right in the middle. What do you see in that 2-column proof? It's kind of right in the middle. Right underneath the a squared plus b squared equals c squared. It says statement, reason, and underneath reason, what's that very first reason? Given. Doesn't even matter what we're filling in the rest. We just know that first reason is given.
So no matter what on your test, you are guaranteed a point right now. If you can remember to just write that word, given. Okay? That first step is always what's given to you. All right, so then who can tell me, what would I need to do next?
Can I use the restroom again? I didn't write the first thing you wrote, but I'll just copy
Yes. Yes, and then use the restroom and then come right back. Is someone at the bathroom? Okay. Can you sign good or not? All right, what would I do next? Distribute. Very good. So our next step, step B, if you would like to write that all out, you could. I'm just going to write what we know. So what is 3 times 2x? 6x. And 3 times 4? 12. And that property is the distributive property.
You don't even know my name? You're going to be tough time on that song. Yeah.
So remember that reason is kind of telling what we did or justifying our steps. So Hamza said first we need to distribute to undo those parentheses. I'm going to say prove it. And we can prove it with this property. The distributive property lets us multiply to undo our parentheses. All right, what would I do next? Subtract 12. Good. How did you know to subtract? Hold on. Good, because I'm trying to get the x by itself, so I want to move away from it, right? So I'm going to move this away from it, and what I do to one side, I have to do to the other. What property did we use? Good. So that's that subtraction.
Now, you might see this written differently. You might see this written as, in step B, it would say 36 equals 6x plus 12. In step C, they write 36 minus 12 equals 6x plus 12 minus 12. It's really the same thing. They just are wanting to do it horizontally instead of working their way down. But since I know most of you went to school in St. Cloud for the last couple of years in algebra, normally we worked our way down. Most teachers teach it that way. So you might see it like this, where you see that minus 12 off the sides. But for our purposes, just to get used to writing proofs, we're just going to worry about writing it vertically.
Go on. Yeah. Does anyone have a whiteout in their basket? We're running short on them. They're all done broken. Yeah, that's all right. Let's go from here to the next step. Now, Horan already kind of said it when she said because we want to get x by itself. But remember, if we're given this if-then statement, this tells us right here what we want our final answer to look like. We want it to look like x equals 4. So that's what we're working towards. So what would we need to do next? I know for D, what is 36 minus 12? 24 equals, and we didn't really touch that 6x yet, but we did 12 minus 12. What's 12 minus 12?
0.
0, so that's gone. So what property says I can now rewrite this with our new values? If you need to look back, go ahead and look back. what property says we could switch it out? I don't have to keep writing 36 minus 12 every time right now. I can switch it out for what it's equal to. Substitution. So from now on, I could just substitute that. And I don't want to write property of equality every time, so I'm going to use that POE. But you can sure write it out.
Capital E, capital P, because those are our words we would capitalize. I don't know, what causes you to capitalize things?
It's kind of important.
Important.
Yeah.
Property and equality,
So you don't.
super important.
You don't usually capitalize conjunctions or articles.
Isn't of is a preposition.
Preposition. Yep.
Preposition. Of, over, into, above, below, through,
Yeah. All of those things.
off. It's a bee and a beehive. I don't know why my language arts teacher taught me.
Yeah.
All the things a bee can do with a bee.
Yeah, that's a really good image.
Above, below, in, on.
Around, yeah. All right, let's look at step B. What would we do next?
How are we going to get the x by itself now?
Good. Divide by 6. Remember, you could do that fraction line. That's usually what I like to do. For this, I'm going to use the divide symbol because it'll be a good visual for us. So step E, we divide by 6. So what property is that? Division, property of equality. Yep. All right, now I want to look at what math, or what would I actually get when I take 24 divided by 6?
You'll see tomorrow. You won't do that today.
4. Okay, so now we're going to use that same step, just like we did above, when we could just rewrite. Instead of writing 36 minus 12, we just substituted. We rewrote it for 24. We're going to do the same thing here. Okay, and that was substitution.
Some people like to abbreviate substitution with sub, but why would we maybe not want to write sub property of equality?
Subtract.
Yeah, it could be confusing with that subtraction property of equality, so unfortunately you just gotta write up the whole thing.
All right, now we have 4 equals x. Who can remember, what do we want our final answer to look like? X equals 4, so we're not quite there yet. We actually have to use one more property. We know we're close, but we have to do one more thing. Which property of equality tells me I can just rewrite this as x equals 4? Good, symmetric. So our final property we're going to use is that symmetric property. Now our final answer looks like the then statement, our conclusion from up top.
So when you do your test, not yet, it's going to be a while, so don't panic. What 3 parts should you always get no matter what? What from this problem, what parts did you know for sure already? It didn't say distributive problem. What did you know right away? You knew this part, the if, the hypothesis. And why do you have a hypothesis? Always given. And what do you know we always have to end with? The then part. What's the then part called in an if then? Conclusion.
The conclusion, yep.
The conclusion. So you should always have this one, and this one ready to just always have.
So no matter what, you should be able to fill in the given as your first step and then your conclusion at the end.
Now, one of the reasons why we label them as we go is so that if you need to explain this to someone, you can just talk about, okay, in step E. And if I say step E, do we all know which part we are looking at? Yeah. Okay. So that's part of the reason we do that is so that when we're looking at a peer-reviewed proof, we can look at it and just call out just the parts we want to. We don't have to talk about every single step.
Okay, so for your practice today, you're going to be doing something really similar to this, but instead of writing all of these down, it's going to be a drop-down menu. So you're going to be doing a Google assignment, which is one that will show you, it'll highlight green or red. If you have the right answer, it'll highlight it green, and you'll know you're right and you're ready to move on. If it highlights it red, you know you have a mistake and you need to go back and check it. You will not have to type all of this. It's going to be a drop-down choice for you. So now you can go to the week 6 folder in Schoology, and you can start your B or 2-6 practice what?